Hi Varuna. Today I'm going to make my first video in the science channel, and this video is going to be for chemistry. Chemistry, today we are going to discuss about pH. pH is known as the percentage of hydrogen in any chemical or given liquid solution or anything which is chemically proven. pH is denoted by lowercase p and higher-case h, which makes pH. In acids, there is a high number of pH, I mean hydrogen, and in bases there is no H or less amount of hydrogen. But there is presence of hydroxide, which is OH. So today we are going to test which of these chemicals are basic and acidic and neutral in nature. So for knowing this, we need some apparatus. We need hydrochloric acid, which is an acid. You can take many acids. I am taking a kitchen chemical also, which is vinegar, a base, which is sodium hydroxide, our kitchen base, which is baking soda, which is known as sodium bicarbonate, phenolphthalein indicator, which indicates the presence of bases, pH paper, methyl yellow, droppers, not one, more, test tubes, beaker, wash bottle, and gloves. So let's start. First, let's test the pH. So I have two pH papers. So on this one, I'm taking a dropper. I'm cleaning it off. Clean it off. Now I'm going to take hydrochloric acid. Only some amount. Just a single drop. Be careful with acids. You can see it has turned pink. Now on the same pH paper you can use another, but I'm using it for acids. I'm taking vinegar. Vinegar is an edible acid which is known as acetic acid. I'm going to add another drop on it. You can see the same part has turned red. The pink part is turned due to hydrochloric acid, which indicates high concentration, and red, which is approximately 4 pH, is for vinegar, because vinegar is diluted acetic acid. So I'm going to dispose it in the base. So now we are going to take another pH paper and now test on bases. So I have a base called sodium hydroxide. Taken another dropper, not this one. I'm going to take another one. Just take a single drop. Drop it off. You can see by adding a single and a minute drop of this, pH paper had turned blue, which indicates that it is a base. The same pH paper, I'm going to add some sodium bicarbonate. This is this. Now add some water in the same spatula. And pour the small amount of solution. On this. You can see the solution had turned a light bluish green color because this sodium bicarbonate is not too basic. So now we are going to use phenolphthalein as an phenolphthalein for indication of acids. So this is phenolphthalein indicator. I'm going to take a test tube, wash it. In a wash bottle is mostly clean distilled water. So this is phenolphthalein. Clean my dropper again. And I'm going to add some phenolphthalein solution. It's clear solution, you can see, clear, totally clear. Slightly milky to say. You can see. And I'm going to add hydrochloric acid to it. This is another dropper. Hydrochloric acid to it. You can see there is no change in adding hydrochloric acid. But now comes the change. I'm going to add sodium hydroxide, which is a base, and now the solution will turn pinkish. And again, observe carefully. So pink. Again, some bubbling is happening because acid and base react to form a salt, and there is a neutralization reaction happening. You can see when I shake the test tube, the liquid inside it has been neutralized, and you can observe that the phenolphthalein indicator has faded away. The pink color has faded away because when acid and base react, they form a salt which is not acidic or basic but a neutral in nature. So I'm gonna dispose the liquid. Take another test tube. I'm going to take some methyl orange this time. Methyl orange. Add a few drops in it. This is another test tube. So now I'm going to add first a base. So this is an orange color. A base in it. You can see there is no color change in it. But now there comes the color change when we add an acid. You can see it's in orange color, but when we add drop of acid, it turns red. Then the reaction between the base and the acid happens. Add some more sodium hydroxide. You can see after adding some more sodium hydroxide solution, it had become orange. because you can see like the before reaction also. We're adding a base and an acid which react to form a salt which is neutral in nature. So when we added a base, it didn't react with the phenolphthalein or methyl orange. But when we added an acid, the acid reacted with the methyl orange and it formed in a yellow color. But when we added some more base, it reacted with the acid and formed a salt, which is neutral in nature. So this neutral in nature doesn't show any reaction with methyl orange, and thus remains its same color. So we're going to dispose. And thank you, and do subscribe to my channel. Like, share and subscribe.